Good evening, Bearcats. We're going to go ahead and do 2.6 Day 2, Polynomial and Rational Functions. We're dealing with rational functions and sketching graphs tonight. We're going to focus most of our attention on slant asymptotes and the possibility of having a hole in your graph and what that means. I'm going to go over the process for graphing rational functions, and this is true for all of them. And then I'm going to do two examples, one with a slant asymptote and one with a slant asymptote and a hole in the graph. I believe that you will see a slant and a hole, maybe not in the same problem, but I believe you will see those on your test. And then at the end of this, I have 5 problems that I want you to go to your text, and I want you to work between now and when you come to class on Monday. On Wednesday, because I won't see you tomorrow. And if you're 18, please go vote. Anyway, I'm going to come by Wednesday at the beginning of class and give you a 0 or 100 for having these 2 examples and the other problems worked out. And then that way we'll have Wednesday and Thursday to review for our test that is on Friday. All right, let's get started. Process for graphing rational functions. 1, we're going to factor everything that we can. And if we have a cancellation, we'll have a hole in the graph. Also, a hole is often referred to as a removable discontinuity. I think that we will just probably call it a hole in the graph in here. We're going to look for our vertical asymptotes. That's what makes the denominator 0. All right, and that would be something you put on your note card. Your restrictions or your excluded regions. So the same as your restrictions are what make the denominator 0, which is also your vertical asymptote. Your horizontal asymptote, this is where you compare the degree of the numerator with the degree of the denominator. If you do not have a horizontal asymptote, then you may have a slant asymptote. We're going to talk about that today. This occurs if the degree in the numerator is greater by 1. Remember, on horizontal asymptotes, if the degree at the top is bigger, I'm going to draw this. This would be in the numerator. Then you have none, or horizontal asymptotes, none. If the top is smaller, then the horizontal asymptote would be y equals 0. And then if the top is the same, then it's the coefficient over the leading coefficient. And that's in a previous video, but I just wanted to remind you of that. All right, we're going to identify X intercepts. That's what makes the numerator 0. We talked about that today in class. We're identifying the Y intercepts. That's when X is 0. Remember, these two are sort of paint by number, that the X intercept is when, the Y value is 0, and the Y intercept is when the X value is 0. You're just kind of substituting in that thought process. We're going to find any additional points we might need on a t-table. We'll talk a little bit about that, and then we're going to graph. All right, let's go ahead and get started on these 2 examples. The first example will be from your assignment, which should be done while over the tomorrow on Tuesday, tonight or Tuesday night. So you have a couple of nights to work on this as well. And we are on page 194 to 195, and this happens to be problem 59. All right, problem 59, the function we're given is x cubed over x squared minus 1. The very first thing we're supposed to do is we need to factor all the things that we can. I'm sorry, that's not the rest of our problem. The rest of our problem is equals. Sorry, that is our problem. That's going to equal. We're going to factor some things out. At the bottom, we're going to factor, this is a difference of squares, so x plus 1 and x minus 1. And in the numerator, you could factor out, you have 3 x's actually. I don't know if that really is going to matter to us too much. That would be a multiplicity. Your zeros would be a multiplicity of 3, which means that you would cross through the axis and wiggle a little bit as it crosses through. And that might make important. So in a minute when we look at the zeros, we'll talk about that. Remember, with zeros, we can have a multiplicity. All right, the first thing we're going to do is we're going to talk about, let's just go ahead and talk about those zeros. Zeros, remember, are your X intercepts. That's when your entire equation is equal to 0, and we talked about that today, or when y is equal to 0, and or you're going to have some value 0. Okay, all those things kind of mean the same. I just kind of want you to get used to thinking that way. Those are all the things in your head that you're thinking about. All right, so what makes an entire fraction 0 is what makes the numerator 0. What makes the numerator 0? And in this particular case, the numerator would be 0 if x were actually 0. So our zeros is x equals 0, or 0, 0 as an ordered pair. That will also be a y-intercept, by the way. Next, we'll take a look at y-intercepts, but you're going to find the same thing. That's when x is 0. So if I made this x a 0 and you made this x a 0, this would be 0 over negative 1, which would just be 0. So that's both our x and our y-intercepts. The next thing we're going to look at is vertical asymptotes. I'm going to go ahead and graph as we go. On your test, you'll actually have a grid, but I'm going to go ahead and sketch as we go. Since we know our x and y-intercepts at 0, 0, we might as well put a point there. All right, and that's all we really know so far. Our vertical asymptotes are what make the denominator 0, or our restrictions. Okay, so whatever you would say x is not equal to, that is what x is equal to for a vertical asymptote. So in this case, x could not be negative 1 or 1, and therefore our vertical asymptotes x would be negative 1 and 1. So let's go ahead and draw those in. So at negative 1, we're going to have a vertical asymptote. I'm just going to kind of squiggle that line right there so you know it's a vertical asymptote. And at 1, I had a highlighter. I prefer using a highlighter probably on my test or on my paper. All right, so those are our vertical asymptotes. That means your graph is going to be in 3 different parts. You're going to have 3 different parts. The next thing we're going to look at is horizontal asymptote. Horizontal asymptote, we're going to compare the degree of the numerator, which in this case is 3, with the degree of the denominator, which is 2. And remember, we just talked about that. If the degree in the numerator is bigger, the top is bigger, then we have none. We don't have any horizontal asymptotes. And if it is larger by 1, in this case it is, then we probably have a slant asymptote. How do we find a slant asymptote? We're going to divide. We're going to use long division and divide. So I'm going to come out here and do that. So we're going to take our x cubed, and we're going to divide by x squared minus 1. And then the remainder won't matter to you. It's just the value that you get at the top. So x squared times something gives you x cubed. That would be x. That would be x cubed, and then that would be a negative x. You change both the signs, and we do long division. These would cancel, and you have x. Since the degree here is smaller than the degree here, then that would be actually a degree of 1. Then this becomes a remainder. I don't care about the remainder, I only care about this. So we now know our slant asymptote is y equals 0. I'm sorry, y equals x. Sorry about that. So that is just the y-intercept would be 0, and it's a slanted line through the origin. That's just your basic standard linear equation with a slope of 1, and so your asymptote would look something like this. All right, now that has divided up our graph into several regions. We have the region on the right side of the asymptote over here and over here. We have on the left side over here and down here. And then we have in between, we're going to have some graph in between. Often in between, there's some really funny things between asymptotes that can happen. They can be above the asymptote, below the asymptote. The one thing you can count on, you will not ever cross a vertical asymptote because your equation will be undefined, but occasionally you can cross a horizontal or vertical asymptote. So just so you're aware of that. Occasionally that happens. You just have to plot some points to figure that out, especially if you have more than one asymptote going on. Let's go ahead and talk about domain and range. And it's a little hard to do that right now, except our domain could be any value except whatever the restriction is. So whatever our vertical asymptote is, our domain is restricted there. So x cannot be, your x values cannot be negative 1 or 1. The range, we're going to need to look at our graph before we decide the range. If there is no horizontal asymptote, though, then we're going to just exclude our range and just say it would be all numbers. So we'll just say it's negative to positive infinity, because in this case we don't have a horizontal asymptote. If we have a horizontal asymptote, then our range could be restricted, at least potentially. All right, so let's now figure out how we graph. We don't have much to go on. We only have one point, and we have our vertical asymptotes. We need a t-table to determine some additional points. So let's do that. If I create a little t-table over here, I'm just going to pick values for x and find out what my values for y would be. Excuse me. And if I do that, let's just pick some values. Let's pick, let's see. We're going to go on either side of your vertical asymptotes. So if our vertical asymptotes at -1, then let's pick like -4 and -3 and -2 and see what happens. And then we already know what happens at 0. So we really like to know what happens maybe in between here. We would like to know maybe what happens in between here. So let's pick 1/2 and -1/2. And then on the other side of our asymptote, let's pick 2 and 3. All right, so if we plug in a 3, I think it's easier to use this factored form of the equation to plug in, and so I just plug into each of the x values and then just write it down. I think it just makes it easier. So if I plug in a -3 and I cube it, I'm going to get -27. And if I plug in a -3 here, I'm going to get a -2. And if I plug in a -3 here, I'm going to get a +4. No, I'm sorry, a -4. So here's really what I'm most interested in on the left side of the vertical asymptote. Am I above or below the slant asymptote? Well, partly that's going to be, in here I'm going to have positive negative, so that's going to be -27/8. And that's going to be, what, -3 point something? -3 point something. And so we're just going to have to know that this actually would have been -1, so it's going to be down here in this little corner, and -3 point something is going to be down here, and therefore we would go toward the asymptotes, and this is kind of hard to tell in this graph, like this. All right, most of the time they're going to be diagonal of one another, but not always, so let's go ahead and check it out. So if I plug in a +3, you would get 27, I would get 4, and I would get 2 at the bottom again, and a positive, so it would be a +27/8. And so again, this is at 1, 1, so at 3, I would be up here at 3 point something, and my graph would be in here, and my graph would kind of go toward this asymptotes. And it would look something like that. All right, so go ahead, you can plug in -2 to get another point, and we could do that. I'm going to do that. 2 squared would be, or 2 to the cube would be -8. And then 2 plus 1, or -2 plus 1 would be a -1. And -2 minus 1 would be a -3. So you have, that's a positive in the bottom, so you have -8/3. And so that's a little less than 3, so that's going to be a little bit closer. It's going to be up a little bit higher. And the same thing's going to happen here. We're going to get a +8/3. And again, that would have made our graph. This would have been here, and this would have been back down here. Should have plotted those better. And on a graph, you'll be able to see it a little bit better. All right, let's see what happens in between. What happens at -1/2? -1/2 is going to be kind of tricky. I'm going to kind of do my work up here just to fill in a little bit. If I take -1/2 and I cube it, I'm going to get a -1/8. So I'm going to have -1/8. And in the bottom, if I take -1/2 and I add 1 to it, I get +1/2. So I'm going to say divided by, I'm going to do old-fashioned, +1/2. And if I take -1/2 and add a negative, that's going to be -3/2. So I'm going to get -1/8 times, and in this case it's going to be a positive times a negative, so it's going to be a negative, and that's -3/4. I'm going to multiply by the reciprocal, so -4/3. The negatives will cancel. This will become 1, this will become 2, and it looks like I'm going to get -1/6. So it looks like I'm going to get -1/6. So if I come over here at 1/2, I'm going to be at -1/6. So it's going to be barely below the line. All right. Because it's above the slant asymptote, we're going to think that it goes up toward the slant asymptote on this side. And it actually is going to come down and kind of cross through and come down this way. How do we know over here with positive 1/2? Positive 1/2 cubed would be positive 1/8. And then we would divide by, and positive 1/2 plus 1 would be 3/2, and positive 1/2 minus 1 would be a negative 1/2. And if I multiply, that's negative 6/4. No, negative 3/4, sorry. And if I take the reciprocal, I'm going to have 1 over 8 times 4 over negative 3. And the 4 would cancel, and that would become a 2, and I get negative 1/6. So I get negative 1/6 as well. So notice these are almost equal here. They're going to get really close, how it flattens out. And that's because we had that cube. Remember, we had a multiplicity for our 0. All right, that was a little complicated. So if you can kind of understand that, or at least the process, that's really good. Let's go on and work on problem number 63. We have 2x cubed minus x squared minus 2x plus 1. And on the bottom, we have x squared plus 3x plus 2. All right, we got a lot of factoring to do here. The top can actually be a divide and conquer problem. You can split it in half, factor out on the left side, which would be your x squared, and you would have 2x minus 1. On this, you're going to factor out a negative 1, and you would get 2x minus 1. So all of this, I'm just going to make this a little easy. We're going to cross that out. This will become x squared minus 1, and it'll become 2x minus 1. Now, we got another little issue. This is a difference of squares. So really, all this will become x plus 1, x minus 1, and 2x minus 1. In the denominator, we're going to factor real quickly, and we're going to have x and x, multiply to 2 and add to 3, which would be plus 2 and plus 3. Plus 2 and plus 3. Oh, plus 2 and plus 1. Sorry. Plus 2 and plus 1. All right, notice we have a cancellation, the x plus 1 with the x plus 1. They're going to cancel, and that's going to be our whole in our graph in just a minute. So I'm going to write down here whole. And I know my whole is where this would be 0, which would be negative 1 for my x value. I'll find the other value for that in just a minute. Once I find that whole, I'm going to go ahead and simplify my equation. My equation now is x minus 1, 2x minus 1 over x plus 2. Let's go ahead and identify everything really quickly. Let's see our zeros, which are what makes the numerator 0, which would be a positive 1. And a positive 1/2. Those are our zeros. Our y-intercept is when x is 0. And if x is 0, then all of a sudden we'd have a negative 1. We would have a negative 1. So a negative 1 times a negative 1 is a positive 1. And we have a 0 here over 2. So 1/2. 0, 1/2 would be our y-intercept. Let's now talk about our vertical asymptotes. Our vertical asymptotes are what make the denominator 0, which is negative 2. So x equals negative 2. And then last, let's talk about our horizontal asymptotes. Our horizontal asymptotes, let's see. Our degree in the numerator would be 2. The degree in the denominator is 1. Greater on top, so we don't have one. But we could have a slant asymptote. So we'll take a look at that next. All right, so let's go ahead and figure out our slant asymptote. We're going to divide. We're probably going to want to multiply this together to divide, which is a little bit of work for you, but none too great for you. All right, so if I multiply these together, I'm going to end up with 2x squared. I'll end up with a negative 2x and a negative 1x, so I'll have a negative 3x, and 1 times 1 is positive 1. And I want to divide that by the denominator of x plus 2. So when I do that, x times something gives me 2x squared. That will be a 2x. So 2x squared and 2x times 2 would be 4x. Remember, long division, you're subtracting both. This cancels. I have negative 7x plus 1. And then again, x times something gives me negative 7x. That will be a negative 7. So I have a negative 7x, and I have a negative 14, and I would subtract both so they get changed. This would cancel, and I have 15, which is my remainder. And I don't really care about the remainder. I really only care about my slant asymptote, which would be 2x minus 7. So y equals 2x minus 7 would be our slant. Let's take a quick look at the graph. We're going to graph our zeros at 1 and 1/2, so at positive 1/2, and again at 1. And again at 1. The next thing we're going to do is put in our vertical asymptote, which is at negative 2. Here's our vertical asymptote. We don't have a horizontal asymptote, and our slant asymptote, again, it's kind of hard to show without a grid, but our slant asymptote, the y-intercept would be way down here at negative 7. And our slope is 2. So up 2 over 1, up 2 over 1. And actually that's probably up 2 over 1 would be the first one. It's going to look something like this, our slant asymptote. All right, and so we need to go ahead and graph our graph. There's only 2 pieces to this graph. And again, this is a little skewed because I don't have it on a grid. So let's take a look at what we know. We know we have a y-intercept at 0, 1/2. So we have 3 points right now. So the next thing we want to do is go ahead and create a little t-table to find a couple more points so we can finish graphing, and then don't forget we need to take care of this hole in the graph. Alright, since our vertical asymptote's at negative 2 and we already know what's happening at 0, let's see what happens at negative 1. Again, it's easier to plug back into the factored form, so negative 1 minus 1 would be negative 2, and negative 1 times 2 is a negative 2, negative 1 is negative 3. And we would divide by negative 1 and 2, which is 1. And so that's going to be positive 6. So at negative 1, we're going to be way up here at positive 6. And you can tell that the graph is coming down like this. And then it's going to go up and follow this vertical, or this slant asymptote. So it's going to come down, it's going to go through these points, it's going to curve and come back up toward this slant asymptote. All right, on the left side of negative 2, we're going to take negative 3 and plug that in. Again, we're using the one that's factored. Negative 3 and negative 1 would be a negative 4. Negative 3 times 2 is negative 6. Negative 6 and negative 1 is negative 7. And negative 3 and 2 would be a negative 1. At the top, we'd have a positive 28. At the bottom, a negative 1. That's negative 28. So really, really far down. It's going to be below our slant asymptote. And I've run out of room, but it's going to be right down here in this corner. All right, let's go ahead and finish this information about the hole in the graph and find out exactly where that hole would be. We know the x value is negative 1. If you have a negative 1x, then automatically you can find a corresponding y value by substituting it in. So let's do that. So if I take a negative 1 here and negative 1, I would get negative 2. If I take a negative 1 here, I have a negative 2 and a negative 1 is a negative 3. And in the bottom, if I have a negative 1 and a 2, I have a positive 1. So at the top, 2 times 3 would be 6. 6 over 1 would be 6. And all of a sudden, our hole in the graph would actually be at negative 1, 6, which was right there, and that would be a little hole in our graph. All right, I think that's it, and make sure tonight that you, between now and Wednesday when you come to class, you finish problems 55, 57, 61, 73, and 75. You do have one problem like this, and you have several like these. I'll check this at the beginning of class, either 100 or a 0 for doing them and for having these 2 problems in your notes. All right, have a great night, and go Bearcats!